This is Mrs. Wainwright's Math Class, Chapter 6, 7, and 8, Packet B, Lesson 2, Simplify Fractions, otherwise known as reduced fractions, and otherwise known as putting fractions into lowest terms. Today's learning target: by the end of this lesson, you should confidently be able to say, I can fully simplify fractions, I can fully reduce fractions, and I can put fractions into lowest terms. If you do one, you did them all, since they all mean the exact same thing. So a fraction is, in simplest form, fully reduced, and or in lowest terms, because those all mean the same thing, when 1 is the only common factor of the numerator and the denominator of the fraction. So if 1's the only common factor of both the numerator and denominator, that fraction is in simplest form, fully reduced, and or in lowest terms. We fully simplify a fraction, or reduce it, or put it in lowest terms by finding the GCF of both the numerator and denominator and dividing both by it. Let's see how this is done. Question number 1 says, write 12/20ths in lowest terms. So to do this, first I'll rewrite my given fraction, which is 12/20ths. Now I'll find the GCF, greatest common factor, of both my numerator and denominator. My numerator is 12. So the factors of 12 are 1 and 12. Does 2 work? It has to. 2 is an even number. So 2 times what is 12? 6. Does 3 work? Well, 1 plus 2 is 3. And 3 is divisible by 3, so it has to. 3's partner is 4. Does 4 work? Oh, it's already there. So those are my factors of 12. My denominator is 20, and my factors are 1, and its partner 20. Does 2 work? It has to. It's an even number. 0 is an even number, so 2 times what? 2's partner is 10. Does 3 work? Well, 2 plus 0 is 2. Nope, 3 is not going to work. Does 4 work? 4, 8, 12, 16, 20. Yes, 4 does work. 4's partner is 5. Does 5 work? Oh, it's there. So I'm done. I now have the factors of 12 and 20. Let's go ahead and find the GCF, the greatest common factor. So I look at 12. Do I see that as a factor of 20? Nope, 12 is not going to work. I look at 6. Is that a factor of 20? Nope, 6 isn't going to work. I look at 4. Is that a factor of 20? Yes, it is. So my GCF of 12 and 20 is 4. So I have to divide both 12 and 20 by 4. Anytime I work with a fraction, if I'm going to multiply or divide it to keep the fraction equivalent, equaling the same amount, and that's what lowest terms is, I need to keep it the same amount but with lower numbers or lower digits, I need to multiply or divide by the same number for both the numerator and denominator. So to help myself remember that, I use what's called a window box. Every time I'm working with fractions, I use a window box. Here's my window box, and if you look at it, it kind of looks like a window that you see at a lot of houses, right? Well, in this window box, I notice that the top pane of the window is the exact same size as the bottom pane of the window, and for most windows it is that way. So the window box reminds me that whatever I put on the top, I must put the exact same number on the bottom. They cannot be different. So I take my GCF, which I found was 4, and I put that in both the top and bottom of the window box, because inside the window box each number has to be the same. Now my directions tell me to put this fraction, 12/20ths, in lowest terms, which is also called simplify the fraction. Or sometimes you might hear to reduce the fraction. All of these words, lowest, simple, from simplify, reduce, are all words that mean to make it smaller. So if I wanted to make 12/20ths into smaller numbers, would it make sense that I'd be multiplying or dividing? Well, when I multiply numbers, my answer is bigger, so that doesn't make sense. But when I divide numbers, my answer is smaller than the number I started with. So it makes sense that I will be dividing by the window box. So now we go ahead and solve. I do need to put an equal sign since I'm changing the fraction. And 12 divided by 4 equals 3. Put my fraction bar. 20 divided by 4 equals 5. So 12/20ths in lowest terms equals 3/5. And that's my final answer. Please stop the video and complete worksheet number 1 right now. So we need to take a minute to talk about what we're doing here, why it works, and why it actually makes sense. Let's take a look at this example. Reese has 1/2 of a Hershey bar. Jake has 2/4 of a Hershey bar. Brianna has 4/8 of a Hershey bar. Who has the most chocolate? Well, it seems like Brianna would have the most chocolate, right? Because 4/8, that sounds much bigger than 2/4 or 1/2. Let's take a look at this. So Reese has 1/2 of a Hershey bar. Here's a whole Hershey bar. She has 1/2. Remember, my denominator tells me how many pieces it takes to make a whole. So the denominator of 1/2 is 2. Therefore, the whole Hershey bar is broken into 2 pieces. If I have all of those pieces, if I have 2 pieces, I have a whole Hershey bar. But Reese doesn't have 2 of them. She only has 1 of them. The numerator tells you how many you have or how many you're talking about. So Reese has 1/2. So I'll shade in 1/2 of the Hershey bar. The yellow portion is how much Hershey bar Reese has. Jake has 2/4 of a Hershey bar. So here's Jake's Hershey bar. The denominator, bottom number, tells me how many pieces it takes to make a whole. Jake's number is 4. So this whole Hershey bar is broken into 4 pieces. The numerator tells me how many pieces he has. He has 2. So let's shade in the number of pieces that Jake has. It seems like Jake would have more chocolate because Reese only has 1 piece and Jake has 2 pieces. But really, they have the same value or the same amount of chocolate. The only difference is Reese has 1 bigger piece and Jake has 2 smaller pieces. But look at what's shaded. It's the exact same amount of Hershey bar. So really 1/2 is equivalent to 2/4 because it's worth the same amount. Brianna has 4/8 of a Hershey bar. Well, here's Brianna's whole Hershey bar. The denominator, 8, tells me how many pieces it takes to make a whole. So it takes 8 pieces to make a whole Hershey bar for Brianna. Let's separate this Hershey bar into 8 pieces. Brianna has what the numerator says, which is 4. So let's highlight the 4 pieces that Brianna has. So that's Brianna's 4/8. She has 4 of the 8 pieces it takes to make a whole Hershey bar. Seems like Brianna has more, and she does have more little pieces, but does she actually have more chocolate? No, because Brianna has the same amount of chocolate as Jake, and she also has the same amount of chocolate as Reese. It's more little pieces, but it's still the same total amount of chocolate. They have equivalent amounts of chocolate. So 1/2 is equivalent to 2/4, and it's equivalent to 4/8, even though they look different. So Reese has 1/2 of a Hershey bar. Jake has 2/4 of a Hershey bar. And I want to show you the way that we just showed you how to reduce or simplify or put a fraction into lowest terms will work for this 2/4. So if I look at Jake's fraction, which is 2/4, and I find the GCF of both 2 and 4, put it in the window box and divide, will it equal 1/2? So let's see. Here's my 2. Factors of 2 are 1 and 2. Does 2 work? Oh, there it is. So my factors are done. His denominator is 4. And the factors of 4, the first partners are 1 and 4. Does 2 work? Yes, it does. 2 times 2, up. So I'm done. What's the GCF? I see that it's 2. So if I put that GCF into the window box, and I divide by it to simplify or reduce or put into lowest terms, I say that 2 divided by 2 equals 1, fraction bar, 4 divided by 2 equals 2. So notice that when I fully reduce or simplify or put 2/4 into lowest terms, it does come out to 1/2. So you can see that reducing, simplifying, and or putting into lowest terms does equal the same amount. Let's try simplifying Brianna's amount of chocolate. She has 4/8. So 4 is my numerator, 8 is the denominator. So let's go through the factors of 4. 1 and 4. Does 2 work? Yes, it does. 2 times 2. Oh, I'm done. Let's do the factors of 8. 1 and 8. Does 2 work? It's even, so it has to. 2 and its partner is 4. Does 3 work? No. Does 4 work? Yes, it does, but I have it, so I'm done. Do I see a 4 down there? Yes, I do, so my GCF is 4. So if I take her fraction 4/8, I put my GCF of 4 in my window box and divide to simplify, reduce, or put into lowest terms. I will say 4 divided by 4 equals 1, and 8 divided by 4 equals 2. So notice for Jake and Brianna, when I fully simplify or reduce or put the fractions into lowest terms, it equals the same fraction that Reese has, which is 1/2 of the chocolate bar. My picture does show me that that is correct. But the next question comes up, why does this work? How can I divide a number, get a fraction that looks totally different, but have it be equivalent and equal the same amount? Well, the answer to that is it all depends on what you divide by, and this goes along with why we use the window box. So let's take a look at some Hershey bars to fully understand this better. Here I have one whole Hershey bar. I'll shade it in because I have the whole Hershey bar, so this equals 1 whole. Here I have a Hershey bar. I'm going to divide it into 2 pieces. I have both of those pieces. So how much of the Hershey bar do I have? Well, my denominator tells me how many pieces it takes to make a whole. How many pieces do I have to make a whole? 2. 2 pieces make this whole Hershey bar. How many of them do I actually have that are shaded? 2. I have all of it. So 2/2 is what I have in this picture right. But notice that 2/2 is the same thing as 1 whole Hershey bar. I do have 1 whole Hershey bar. They may be broken into smaller pieces, but I do have the 1 whole entire bar. Let's take a look at another picture. Here's 1 whole Hershey bar. I'm going to break this into 4 pieces, and I have all 4 pieces. So what does this equal as a fraction? Well, my denominator tells me how many pieces it takes to make a whole, which is 4. My numerator tells me how many pieces I have altogether, 4 shaded pieces, so I have 4. What I have here in this picture is 4/4, which is the same thing as 1 whole. Let's look at another picture. Here's another whole Hershey bar. I'm going to divide this Hershey bar into 8 sections, and I'm going to have all 8 sections. So what does this look like? Well, it takes 8 pieces to make a whole, so my denominator is 8. I have 8 of them. My numerator is 8. I have 8/8 of the Hershey bar. I also have the entire Hershey bar, so even though it's 8/8, I have 1 whole Hershey bar. What do you notice about a fraction that shows that it means a whole? 2/2 equals a whole. 4/4 equals a whole. 8/8 equals a whole. So when my numerator is the same as my denominator, it means I have all of the pieces it takes to make a whole, and it equals to 1 whole. So what if I had 16/16? What would that equal? Well, the numerator is equal to the denominator. I have all of the pieces, therefore it's equal to 1 whole. What if I had 97/97? Well, that means my Hershey bar is broken into 97 pieces, and I have 97 of them. So guess what? Again, I have 1 whole. What if I had, let's go crazy here, 1,823 1,823? That means my Hershey bar, oh my goodness, is broken into 1,823 pieces. But guess what? I have all 1,823 of them. Therefore, I have the whole Hershey bar. So when you have a fraction, if the numerator and denominator are the same, you have 1 whole. Let's relate that back to what we know with whole numbers. If I'm given the problem 8 divided by 1, what does that equal? Well, that equals 8. What if I'm given 47 divided by 1? That equals 47. What about 396 divided by 1? That equals 396. So what do we know about numbers that are divided by 1? We know, we've known this for a while, that anything divided by 1 equals itself. Right? 8 divided by 1 equals itself, 8. 47 divided by 1 equals itself 47. 396 divided by 1 equals itself 396. And we also know that when the numerator and denominator are the same in a fraction, that fraction is equal to 1. So therefore, when I'm simplifying or fully reducing or putting a fraction into lowest terms, and I'm putting the same number inside both the top and bottom of the window box, like 2 halves, I'm really dividing by 1. So even though my digits look different, I'm kind of playing with the numbers here, right? 2 divided by 2 equals 1, 4 divided by 2 equals 2. I'm still truly dividing by 1 because 2 halves is the same thing as 1. And here, 4/4 is the same thing as 1, so I'm truly dividing by 1. And that makes sense that when I reduce, each of my chocolate bars are actually the same amount of chocolate. My digits in my fraction look different because I'm changing them and fully simplifying them or reducing them or putting them into lowest terms, but because I divided by 1, and anything divided by 1 equals itself, I did not change the amount that I started with. Okay, so now that we have a better understanding of why this works, let's go back and try example number 2. Question number 2 says, of the 48 students in our classes, 36 made honor roll. What fraction of the students in simplest form made honor roll? So what is this asking me? It asks what fraction of the students in simplest form made honor roll. What do I know? I know that we have 48 students in the classes, so that's the total number of students. I know that 36 of them made the honor roll. So 36 is the amount of students that we're talking about. So if I want to put this into a fraction, I would make the fraction 36/48. Remember, denominator is how many it takes to make a whole. 48 students make the whole group of classes. Numerator is how many I'm talking about. I'm talking about who made honor roll, and that's 36 students. So I have 36/48 as my fraction. And my question asks, what's the fraction in simplest form? I don't have much room left on this page, so let's move to another page to complete the work. So I had the fraction 36/48. Let's take my numerator, which is 36, and let's find the factors. 1 and its partner is 36. I add those digits together, I get 9, so when I'm ready for my 3's. Okay, so let's see, does 2 work? It has to. But I don't know what 2's partner is, so I'm going to do a little division problem right here. I work it out, and I find that its partner is 18. So I write down the 18. Does 3 work? Well, 3 does go into 9, so it has to. Put down the 3, go through my multiples, and I find that its partner is 12. Does 4 work? When I go through my 4 times tables, do I say 36? Yes, I do. 4 times 9 is 36. Does 5 work? Well, it doesn't end in a 0 or 5, so it can't. 6, ooh, I have a 2 and a 3, so it has to be divisible by 6. 6 times 6 is 36, and I never write a number twice, so I am finished. Let's find the factors of 48. Well, I know it's going to be 1 and itself, which is 48. This ends in an 8, and when I add my digits together, I get 12. Okay, does 2 work? It ends in an 8. That's an even number. It has to. 2 times what is 48? I don't know. So let's do a division problem. As I work it out, I find out that 2 goes into 48 24 times. So 2's partner is 24. Does 3 work? Well, 3 does go into 12, so it has to work. But 3 times what is 48? I don't know. So let's do my division problem. And when I work this out, I find out that 3's partner is 16. Does 4 work? Well, 4 times 12 is 48. So yes, it does. Does 5 work? No, it doesn't end in a 0 or 5. Does 6 work? Well, I say 2 and 3, so 6 has to work. 6 times what is 48? 6, 12, 18, 24, 30, 36, 42, 48. So 6 times 8 is 48. Does 7 work? No, when I go through my 7 times tables, I don't say 48. Does 8 work? Oh, there it is. I have it already, so I'm done. Now let's find my greatest common factor. 36, do I see it down at the bottom? Nope. Cross 36 out. 18, do I see an 18? Nope, cross 18 out. 12, do I see a 12? Yes, I do. So the GCF is 12. Make my window box, because whatever I do to the bottom, I have to do to the top. That's why it's dividing by 1. So I put my GCF into both parts of my window box. I go ahead and divide since I want to reduce or simplify or put into lowest terms. 36 divided by 12 equals 3. 48 divided by 12 equals 4. So my fully simplified answer is 3/4. Let's go back and put that into my word problem. So the final question said, what fraction of the students in simplest form made honor roll? My fraction in simplest form was 3/4, so 3/4 of the students made honor roll. And that's my final answer. Please stop the video and complete worksheet number 2 right now. Example number 3 says fully reduce 3/27, and that weird dot there is supposed to be my period. Okay, so when I fully reduce or simplify or put in lowest terms, I have to find the GCF, the greatest common factor of both the numerator and denominator. So my numerator is 3, my denominator is 27. Let's find the factors of both 3 and 27. 3, 1, and itself, which is 3. Does 2 work? Nope. 3, oh, there it is. So I am done. 27, 1, and 27. Does 2 work? No, because it's an odd number. Does 3 work? Well, 2 plus 7 is 9, so 3 has to work. 3 times what is 27? 3 times 9 is 27. Does 4 work? No, when I go through my 4 times tables, I never say 27. Does 5 work? Nope, doesn't end in a 0 or a 5. 6? Nope, it wasn't divisible by both 2 and 3. 7? No, when I go through my 7 times tables, I don't say 27. 8? Nope. 9? Oh, there it is. So I am done. Do I see a 3 as a factor of 27? Yes, I do. So that GCF is 3 will go in both the numerator and denominator of my window box, which makes it like I'm dividing by 1. I want to simplify or reduce or put in lowest terms, so I want to divide to get smaller digits. Don't forget your equal sign. 3 divided by 3 equals 1. 27 divided by 3 equals 9. So when I fully reduce 3/27, the answer is 1/9. Please stop the video and complete worksheet number 3 right now. And our last example, example number 4, says fully simplify 4/32. Now, I want to show you what happens if you don't find the GCF. You just find a common factor and not the greatest common factor. And in real life, this is going to happen because we're human beings. We're not perfect. We make mistakes. I make them all the time. You know that. Everybody makes mistakes. So let's see what happens and how we can solve this or fix it if we do make a mistake. So this example is what happens if I miss the GCF. Okay, so we're going to purposely make the mistake, remember, as we go. So I have my fraction 4/32. I write it down. I find the factors of 4 and 32. Factors of 4 are 1 and its partner 4. Does 2 work? Yes, it does. And it's 2 times itself, so I'm finished. The factors of 32 are 1 and 32. Does 2 work? Yes, it's an even number. It has to. Do a division to see what its partner is. And I get 16. So 2's partner is 16. Does 3 work? 3 plus 2 is 5, so no, 3 doesn't work. Does 4 work? No, it doesn't work. Remember, I'm purposely making this mistake. 5, no. 6, no. 7, no. 8, no. 9, 10. Oh, I think I'm done. Okay, so I have to find the greatest common factor. Do I see a 4 down there? No, I don't. Do I see a 2 down there? Yes, I do. So I think that my GCF is 2. So I'll put that in the window box, and I'll divide. I think everything is going along perfectly fine because I think I found all of my factors. 4 divided by 2 is 2. 32 divided by 2 is 16. So I say, great. 4/32, it fully simplifies to 2/16, and I'm done. But here's a check you can do. It's not the perfect check, but anytime you see that your final answer has both the numerator and the denominator with even numbers, you will know that that is one way to say you did not fully simplify or fully reduce or put that fraction into lowest terms. Because if they're both even numbers, there is a greatest common factor for them that's greater than 1, right? 2 and 16, at the very least, could both be divided by 2. So, every time you think you're done, go back and check your new fraction, your final answer. If they're both even numbers, guess what? You made a mistake. You're not done, so you need to go back and fix it. How can I fix it? One of two ways, whichever way you prefer, is perfectly fine. I can look at this fraction and I can say, 2 is an even number, 16 is an even number, so this is not fully reduced. If they're both even, they're not fully simplified, so that means I made a mistake in my GCF, and I can actually go back to my GCF to check it out and see where the mistake is. So I can say my factors of 4 are 1 and 4. 2 does work. 2 times 2 is itself, so I think I'm good with 4. My factors of 32 are 1 and 32. Does 2 work? Yes, it was even. It had to. I found that its partner was 16. 3 didn't work. Does 4 work? Let me go through my 4 times tables again. 4, 8, 12, 16, 20, 24, 28, 32. Oh, that's where my mistake is. 4 does work, and its partner is 8. Does 5 work? No, it doesn't end in 0, 5, 6. It's not divisible by both 2 and 3. 7? Nope, 8, and there it is. So I'm done. Now I go back and look and I say, oh, here's where my mistake was. My GCF was not 2, my GCF was 4. So I would simply rewrite my fraction 4/32, put my correct GCF of 4 into my window box, divide, and I would find that I came up with 1/8. Another way you could do it, if you prefer, is just look at that 2/16 that we have up there circled in red. And again, when you say, wait, my numerator and denominator are both even, that can't be. And I know that if the numbers are both even, they have to be at least divisible by 2. I could just go ahead and add another window box here, put the 2 inside of each side of it, and then I could divide from there. And I would say that 2 divided by 2 equals 1. 16 divided by 2 equals 8. I would do a quick check. 1 is not an even number, so it's not like I have both even numbers anymore, and I could say, okay, my final answer is actually 1/8. So if you miss the GCF and just do a common factor, that's a quick check. And if both numerator and denominator are even, you have to go back and fix it. And again, we're human beings. We're going to make mistakes. There's a lot of these problems. You're going to see that sometimes I make a mistake too, because I don't think any of us are going to get through this unit without making mistakes a couple of times. So here comes the question then. How can you be sure that you're done? Well, we know if both the numerator and denominator are even, you're not done. But what if one of them is odd or both of them is odd? Well, here are some little tricks to help you know that you're definitely done. If my final answer was 1/8, I would be able to look at that fraction right away and say, oh, I'm definitely done. Why? Because when there's a 1, I am done. So if your final answer, your final fraction has a 1 in it, you know you're done. How else would you know that you're done? What if my final answer was 3/4? 3 is an odd number, 4 is an even number. How would I know I'm done here? Well, when they're in counting order, I'm done. Look at that. Look at your numerator is 3, your denominator is 4. That's counting order, right? 3, 4. Or if you had 5, 6, it's 5, 6. Or if you had 8, 9, it's 8, 9. So when they're in counting order, they're done. And when they're in counting order, they're kind of 1 away from each other, right? 3 plus 1 is 4, right? So if they're counting order, they're 1 away from each other. How else might you know that a fraction is done? What if my final answer was 3/5? There's no 1. They're not in counting order. They're not both even, so maybe it's done, but I'm not sure. Well, a quick way to check is when the GCF is 1, I am done. So you would take what you think is your final answer, and you would find the GCF of the two numbers. Now these numbers are going to be smaller, so it should be fairly easy to do that. What are the factors of 3? 1 and 3. Does 2 work? No. 3, I'm done. What are the factors of 5? 1 and 5. Does 2 work? No. 3, no. 4, no. 5, I am done. So let's find the GCF. I don't see a 3, but I see the 1. And when the GCF is 1, I am done. So go back up to the orange. When there's 1, I'm done. Black, when they're in counting order or they're one away from each other, I'm done. And the green, when the GCF is 1, I am done. Therefore, when reducing or simplifying or putting fractions into lowest terms, 1 means done. That's just a good check. So now that we got through the video, I know it was a bit long, but it was important. Shh, there's a bonus for watching the whole video. Do not complete example number 4. Simply put a smiley face on the answer line. Keep it secret. We're going to see how many people really watch the entire video. And the only way I'm going to know you watched the video if there's no work on number 4 and just a smiley face. I do not want you to do number 4 anyway. It's just a fake problem. So just simply put the smiley face. It's our secret. We'll laugh together tomorrow. So to review, in order to put a fraction into lowest terms, simplify or reduce, they all mean the same thing. I find the greatest common factor of both the numerator and denominator. I put that number in both the top and bottom of the window box, because then it's like dividing by 1. I go ahead and divide and get my final fully simplified answer. When I'm finished, I do a quick check, because if both my numerator and denominator are even, it's not fully simplified and I need to fix it. And if I see any of these hints with 1, I know automatically that I'm done. So when there's a 1, I'm done. If the numbers are in counting order, which means 1 away from each other, I'm done. And if the GCF is 1, I know that I'm done. Hopefully by now, if not by the time we're done practicing in class, you can confidently say, I can fully simplify fractions, I can fully reduce fractions, and I can put fractions into lowest terms. Because remember, if you do 1, you did them all. They all mean the same thing. As you practice this lesson, if you have any questions, please make sure to see an adult in the classroom. Good luck with the lesson.